In this problem, we're going to be finding tangent of cosine inverse of x, given that tangent's value is positive. So this part right here, the tangent's value is positive, is going to be very key to solving this problem, but we'll have to come back to that later. So what we want to start with here is tangent of cosine inverse of x. We know that whenever we're dealing with any of our 6 trig functions, sine, cosine, tangent, cosecant, secant, cotangent, whatever is plugged into them has to be an angle. So that means this tangent of cosine inverse of x is the same thing as tangent of some unknown angle theta. Which means cosine inverse of x, what's being plugged into our tangent function originally, is equal to that unknown angle theta. And now, just like when we dealt with any type of algebraic equation, even though this is a trig equation, we still want to get our x alone. So in order to get x alone, we need to cancel out this cosine inverse. And the way that we can do that is by finding cosine of each side of the equation. So we have cosine of cosine inverse of x is equal to cosine of theta. Remember, when we're doing this, we're not multiplying each side by cosine. We're plugging each side of the equation, the cosine inverse of x and the theta, into cosine. It's just like if you were taking the square root of each side of the equation. And from here, cosine of cosine inverse will cancel out, leaving us with just the x is equal to cosine of theta. So it's at this point that it's worth recalling that cosine of theta, if you're given some triangle that contains your angle theta, is equal to the adjacent side of the triangle divided by the hypotenuse of the triangle, as long as you're dealing with a right triangle. Which means, in this case, cosine of theta equals x could be rewritten as cosine of theta equals x over 1. We can rewrite anything as itself over 1 without changing the problem. So our adjacent side is going to be x, and the hypotenuse will be 1, given some triangle that we can just construct. So we're going to make sure that this is a right triangle. And now we're going to pick one of these two non-right angles to be our angle theta. It doesn't matter which one as long as we pick just one of them. So because cosine of theta is equal to x over 1, the adjacent side of this angle theta has to be our x, and the hypotenuse of our angle theta has to be 1. Now, from here, in order to find tangent of theta, we know that tangent of theta is equal to the opposite over the adjacent on our triangle. So if we can find this opposite side, we already have the adjacent side. That would give us the value of tangent of this angle theta, which would then give us the value of tangent of cosine inverse of x, since cosine inverse of x is equal to theta. So, remember, our most common formula in mathematics, for the most part, is going to be the Pythagorean theorem, which says given any right triangle, if you add up the legs of the triangle squared, each squared, then it's equal to the hypotenuse squared, or a squared plus b squared equals c squared. So in this case, we'll let our adjacent side x be a, which gives us x squared plus b squared equals c squared, which in this case c is the hypotenuse of our triangle, which we said is 1. So we get 1 squared. Simplifying this, we have x squared plus b squared equals 1. And now we're going to subtract x squared from each side because we're trying to solve for just this value b, which gives us b squared equals 1 minus x squared. And if we want to finally get b alone, we'll take the square root of each side, which gives us b equals plus or minus the square root of 1 minus x squared. And it's at this point that we need to make a connection here to decide whether we want the positive or negative value. So, if we look at our triangle, we're saying that tangent's value is positive. We also know that cosine inverse of x has to be between 0 and pi. So that's just one of our rules for dealing with inverses. So with that, we know that our answer for cosine inverse of x, or theta in this case, has to be between 0 and pi, meaning we're dealing with quadrant 1 or 2 for our angle theta. And furthermore, since tangent's value is positive, then deciding between these two quadrants, the only one of them that tangent is positive in is quadrant 1. So in this triangle, that means we have a positive value on our y-axis and a positive value on our x-axis. In other words, this x value has to be greater than 0, and this unknown side value here also has to be greater than 0. And since this unknown side value is either plus or minus the square root of 1 minus x squared, then we can immediately choose that it is the positive answer because we proved that we are in the first quadrant where our y value is positive. So we get the square root of 1 minus x squared, or the positive square root of 1 minus x squared, which leaves us with tangent of theta, tangent of this angle, is equal to the opposite over the adjacent, which gives us the square root of 1 minus x squared divided by our adjacent side, which is x. And since tangent of theta is equal to tangent of cosine inverse of x, the original problem that we started with here, then that means tangent of cosine inverse of x is equal to the square root of 1 minus x squared all over x.